So we're going to continue with our new chapter. Actually, we're going to talk about how to write the scientific paper, how to write the article, what should be the content, and what you should pay attention more. And I'm going to discuss the key points that you should not ignore, and of course, how to start writing the article from scratch. Okay, like it's not easy to just sit and just come up with a title and just start writing the introduction and continue. No, it doesn't work like this in here. So article requires a bit different way of starting it. Okay, so we're going to discuss these points. Okay, the goal of this chapter basically will show you how to complete a certain paper, okay, scientific paper. So we'll put the question here. You have to know precisely what question you want to answer. Like, this is very critical. Like, you have to know what you're trying to do, what you're gonna write. Second, you will have to know what type of data you're gonna collect. If you know that what you're gonna do. If you don't know what you're gonna do, imagine there's a database and you don't know what to do. So what type of data you need to collect? Is it banking data? Is it economical data? Is it financial market data? Is it stock prices? Is it bitcoins? And so on. So first of all, you have to identify the question that you're working. Like, what exactly you're gonna do. To do that, there's a way to start with. Then you can only know whether you can complete your project like with a given time if you know that whether the necessary data is available. Let's say, is there anyone in the class who knows like what they're gonna do? At least some idea what you're gonna write with your thesis? Anything? Yes?
About IPO situation in the emerging markets, where I'm not sure exactly.
IPO, yeah? Whether the data is available or not, you don't know. Yeah, that's is available.
Yeah, but it's the major concern is how to write the methodology using empirical data, empirical studies.
Okay, at least you have come up with some literature part. Yeah, you know, like, is there something very close to what you're trying to do in the literature existing?
Some drafts from other people who try to propose the methodologies for governments and implement it somehow.
Okay. So it is very important to know like what type of data you're going to collect. For example, when I started writing my PhD thesis, I started to collect the data. Okay, I know somehow like I'm going to do the persistency of the financial performance of financial institutions in 9 countries. Okay, I find out like some certain factors. When I downloaded all the data, I started writing. My supervisor told me, "What are you doing? What is your methodology? What is your model, econometrical model? What exactly you're pursuing? What is your goal objective that you're following? Why you selected the persistency of the companies? Like, why you want to do it?" Like, this type of question need to be answered before going into the collection of the data. Then all the data that I collected were actually useless because I have to start again because my model totally changed. So you can only know if the research question is interest to someone. You can precisely state and discuss with your classmates as well to understand who will be interested in your research. Is it gonna just do it and just get it away, or you want your research, that the output that you're gonna get, to be read, to be heard, to be published? So finding interesting research question, like first of all, you should select the field that you're gonna work with. Like, is it economics, is it finance, social science, or there's something like, is it questionnaire and so on. How you can do it? There are different like links, there are different engines are available, like searching engines, search machineries that can help you to find it. Okay, nowadays the most famous one, but before it was like Google Scholar, like EconLeaks, where you can find the scientific works that are already published within the journals. Okay, or you can go directly to the publisher. Do you know any publisher, any famous publishers? Elsevier, or else
New York Times.
Financial.
it's a magazine, okay, but the publisher for the journals. Like we have a publisher and they have attached some certain thousands of journals. Elsevier, Whaley, Taylor and Francis, Whaley, Springer, this type of the like well-known publishers, Sage, Ender Science, and there are many, there are thousands of publishers actually. So you can search the title through those publishers by finding any articles related to your subject. In my case, I use always like Google Scholar, and recently I started to use ChatGPT. Like, but ChatGPT is basically the problem is that it's updated only up to the 2021. Like you give me a really very hot topic nowadays, which is very concerned that the people are really interested. It can give you. But there's other like artificial intelligence that can help you to search, that help you with finding the really relevant article. So first of all, to start writing it, to start writing your article, to start your writing the thesis, the first thing that you need to start with is your literature review. Like you don't invent the bicycle for the second time. Imagine you start writing something, you wrote, you finished, and you just came to your supervisor, you want to publish, but it's already written before. You need to do something new. You need to do something unique. To do that, you have to go through this type of websites, databases that are available, you can search it. For example, in Elsevier, what I really like it, when you search any certain title, it gives you the article, okay? You select that article. If you want to download that article, while downloading it, it gives you very similar topics, very similar articles that are related to this article too. Like you can download as a lump sum of all articles in the same field. Like I want profitability article. I found it one, and Elsevier gives a suggestion. Do you want to download the others? At the same time, you can download it. So your research project should be something new, like it should add a new variable whose influence has not been studied before. You can expand the economic question to include the factors from other sciences. You can study the existing question for more recent data. For example, I studied the banking profitability for Kazakhstan for 2021. You can do the same thing, but make it 2023. Make it most updated. Use the same variables. Your unique contribution will be what? Adding new data. You can use new data sets or study a question for a different country. I did it for Kazakhstan, you can do it for the country that has not been done before. For the same method, for the same variable that I used it, but use the different country. Make a differentiation that say that Alim Shah used this country, but I'm using my study is different from his with the respect of the country. So try to use the new alternative method to study an question. You can study my question again, but with a new methodology. For example, I'm using OLS, ordinary least square. You said Alim Shah has not used in this study FGLS. You can use the FGLS. And this will be the new study, saying that, look, FGLS brings a different result. So interpretation of the FGLS output will be a different with the interpretation of the OLS, because FGLS is a more advanced if you compare to OLS, or fixed or random effect model that we're going to study today. So as you start, your work should start always with the literature part. And we know that article consists, or any thesis consists of the following: introduction, like abstract, introduction, lit review, method and data, results, conclusion, and references. So this is the kind of structure skillet of the article. So you always start with literature review. once your literature review started, at least, for example, you need to study 20 different studies on your subject. It shouldn't be exactly the same subject, but at least read these 20 subjects. Believe me, reading those 20 subjects, you will create a model which does not exist within this 20 subjects. You will say, my model will be different from this by studying. So you will have an idea. Basically, it will help you to create a model. Based on the model, you will find out like similar, maybe let's say 10 of them used OLS, 5 of them used FGLS, and remaining 5 used fixed effect model. And none of them used panel corrected standard error model. So you say that I'm going to use in this type of study, panel corrected standard error. Having in mind these studies, they have not used this model. I can use the variable, and you can differentiate in terms of methodology, and you can differentiate in terms of variables, in terms of countries, and other things that you can. So first, you need to read the literature review. Even for the article that you're going to write, start with the literature reviews. Try to read, for example, any keywords like what do you want to study? Artificial intelligence, nowadays is very popular, artificial intelligence in finance or in business and in economics. It's very important and it's very crucial, it's a very hot subject. Try it. For example, nowadays, in the case of the Kazakhstan, what is the most important and significant part in the finance? Is frauds, okay, financial frauds that cannot be ignored. Like, try to find like financial fraud and artificial intelligence. Why not? I haven't seen any study related to this, specifically with the Kazakhstan. Artificial intelligence in the financial market. There was a case like the news, one businessman, or he was a deputy. He just shared one information that how easily he earns the money with the bank. I don't know, you heard that news or not? And he was like captured and he was put into jail next day. He shared the information and he just said one word, how he earns the money within certain bank. And that bank sued the businessman. And that businessman now is in the jail. And he said, and that's the way that he earns, he just underlined the artificial intelligence words, like artificial intelligence trade something. Like there's a platform that he uses, but it's artificial intelligence. For example, a friend of mine, he's a trader, he's a really good trader. He's at the same time, he's an engineer. He created a robot that makes a trading for him. But the robot algorithms of trading is based on the neurons of the brain of the human. So he used it. Imagine how complicated the things that he made like as an engineer, and it's good. Another popular subject you can use like ESG. ESG everywhere, environmental social governance. The third one, fintech, financial technologies. It's very popular and it's very hot still topic. Once you have read the articles related, let's say ESG and the finance, ESG and insurance companies and other things, let's say you have come up with a certain model. Now you know what you're gonna do. You have already identified your objective. Now is the time to collect the data. Most of the question can be addressed using some alternative data, okay, like some pure cross-section, repeated cross-section, like pooled cross-section, and final data. And of course, many questions can be, in principle, be studied using the single cross-section. However, you should not limit yourself to this only. And for reasonable ceteris and paribus analysis, one needs enough controls, like you need to control your data set, like not just download it and try to run it. For example, panel data provides more possibilities for convincing, holding all other factors constant, and that can control for time invariant unobserved effects. So example for panel data, like individuals, firms, and cities, countries, and states are often publicly available. So these type of data sets are available online in certain journal archives. You can access the authors directly, the authors can share it. Sometimes the authors, they do share the data if they want, but with some conditions, let's say I will share the data, but you put my name in your article, because this is what my contribution to your new article, because I have collected data, and here you go.
Once I requested data from one research, and the person who wrote the research was in an hour sending this data.
You sent it.
Yes, I was so shocked and reading my mail from this author, and he says, use it.
That's very good. Like it happens because he wants to share the knowledge. If somebody approached like from outside and asked me for data, I will share it. I will not put any conditions, for example. I don't need it like my name to be in every article that somebody is writing like I don't like need it. But there are some authors, they do have this type of intention. They say, I want my name on the article, but this is not something wrong, okay? This is not something unethical. It's a normal, it's a time consumed, like you download the data, you know, it's not easy. Even the databases are ready, and you saw like, you can download it, but the data is not organized. You need to organize it in a way, it should be panel data or time series. So why, by sharing, he may ask to put his name into the article, and it's a like normal thing. It is his contribution to your article. Okay, whenever you just download the data, it can be in different formats, okay, in spreadsheet, in different softwares. So we already discussed different, like how the time series works and how the panel data looks like. It is always important to correctly identify and handle the missing values, okay? Non-numerical data will be always present in your data. So you need to correct it as well. Like as I told you, sometimes if there's non-numerical in a text format, it's like string format. Then you have to convert it into the numerical one using different techniques. Okay, sometimes it happens like in some database, when you download the data, you can see like 909 or -1. This means that they have a missing values, but it is very not practical and not really good. It will give you the biased estimations. So you have to be careful. When you download the data, for example, I downloaded for 500 banks, and I have to just go through each bank and try to see whether there is something like, which looks very like something like superstition, okay, something like unacceptable. Once I download the data, and there's another thing that you need to find a way to use and to understand and measure your variables in terms of checking like summary statistics. You remember that I taught you how to do descriptive statistics. You just type sum and it gives you the mean, standard deviation, and so on. Why you're getting, for the first reason, to understand by how much it shows you. For example, the banks, I downloaded return on equity, okay, ROE, for banks in Kazakhstan. For example, what do you expect the ROE to be in Kazakhstan for banks? Just approximately. Maybe 20%, yeah? But imagine, as an average, in your statistics, you will see like it is like 50%. It's good, okay? It's very high. And there is a mean and max. In the max value, you will find it is equal to 10,000. Imagine how it is acceptable, like 10,000 return on equity in terms of percentages. So this, you should raise a question. There's a question mark in your data set. There's something wrong with your data set. You need to go back and find it. And you may find it like some of the cells by mistake who were entering the data, instead of entering, let's say, 100%, they entered 1,000 or 10,000. It happens because it is the human who puts the data into the databases. And there is a chance that he will be mistaken. But nowadays, they are using the artificial intelligence. They put in the data. Once you have collected data, with a given your research question and data available, so you have to decide on appropriate econometric method that you're going to use. Are you going to use OLS, ordinary least square, FGLS, panel corrected standard error model, fixed random effect, pooled OLS, GLS, GMM? Like there are thousands of different methods. You have to come up with a certain method and justify that this is the method, is the best method. Because when you're going to write it, and when you're gonna apply this method, you have to be sure that this is the really good method. Nowadays, you cannot find anyone who use OLS. Okay, no article. Maybe like first start the beginners, they use OLS. OLS, okay, it's just OLS, ordinary least square. You just type regress, get the result, and interpret. But that article cannot be accepted as a scientific anymore because it is the very simplest way of method nowadays is used, and it's not accepted. You have to go more advanced level. At least maybe to go to fixed effect or random effect. Or beyond like FGLS or panel corrected standard error models and so on. So when making, and there's something else we were making some transformations of data, like taking the natural log logarithms, taking the difference, growth rates, and there you should be very careful as well. Okay. So carefully choose the functional formulas like specification, like logs and squares. At the beginning stage, do not include the variables that are listed as a numerical values, but have a quantitative meaning. Transform match variable to dummy. Like we're going to talk about dummy variables a bit later, because it's very important variable where we're going to create it. We'll how you handle the ordinal like regression in a similar way. Like how you deal with the dependent variable if they're like ordered like logit and probit models. Like logit and probit models, we're going to talk about two. These are one of the ways to go with it. And one can reduce the ordered variables to binary variables, like by converting into the dummy, which we're going to talk later too. Okay, there's some problem which is heteroscedasticity. You remember I told you the error term. What is the error? Can you just remind me what was the error? Something unobserved, like something is not included in the model. Those factors that are unobserved, they have variations, okay? Volatility. If they're too much volatile and distribution of this volatility is not proportional, then it is called a heteroscedasticity. Not proportionally distributed, like cannot be controlled, like very huge ups and downs, not like asymmetrically distributed. If its variation of volatility is asymmetrically distributed, it is called homoscedasticity, like which you can control. When it's not proportionally and asymmetrically distributed, the volatility of this error term, which is heteroscedasticity, it is really bad and you cannot control it. Like kind of shocks ups and downs. You never know when it's going to affect and how it's going to affect. If it's homoscedastic, at least you can have some control on that. So you will select a specific model, like take into consideration trends, seasonality, unit roots, and co-integration. Carry out some mesh specification tests and think about the possible biases. Do the sensitivity analysis at various specification method, and hopefully that when you do these things, the result will not change much. And there are problems always with outside influential data as well, so you need to take into account too. So the key specific assumption that you need to take into account by using the panel data, first of all, when you use the random effect and the fixed effect. So we're going to go today with this random and fixed more deeply by applying in STATA. So basically, it is OLS, okay? It's OLS ordinary least square. When you run the OLS, either you decide to run the fixed effect or random effect model after OLS, because we said the OLS is the simplest and there are many things are violated and ignored. So the first thing, that error term has an impact on the independent variables. And That's why it is advised to move to either to fixed effect method or random effect method. But which one to choose? The Hausman test will tell you. I will show you straight how to do the Hausman test that will help you to select the random or fixed effect. So basically, fixed effect is used when it is believed that there is some individual's effect has got impact on independent variables, which means some errors, some observed variables, specific variable has got the impact on the independent variables. To keep it to like constant, like to put it in a constant level, we use the fixed effect. However, it could be the case that those individuals, those unobserved factors, they do not affect your independent variables. Then we're going to move to random effects. But how to understand whether there is an effect or not? The Hausman test will tell you. If there is, Hausman test will suggest you to use the fixed effect. If not, it will suggest you to use random effect. So basically, random effect tells you that regressors, independent variables, okay, regress is another name called for independent variables, unrelated to individual specific effects, like they are not related. That's why you're advised to use random effects. However, if you find it out that regressors are related to individual specific effects, like there's a relationship with error terms, independent variables, and then you're advised to use the fixed effect to fix those relationships so that it doesn't affect your results, your estimation. So the assumption is more like fixed effect, basically more or less more convincing. And there's like contemporaneous exogeneity, which means error terms are uncorrelated with explanatory variables with the same time period, which means today's 2020, the effect of these variables are not correlated with independent variable in this year. But it could be the case the effect of the error terms of the previous year affecting. Like profitability, let me give you an example. The profits the company generates are affected by the previous profits. If the company doesn't generate the profit in the previous year, it will not have money for this year. And if they don't have the money for this year, they will not run the certain current project. At the end of the day, the current profit will be reduced. So this profit had the last year's profit has got the impact on the previous and the current profit. Any other things could be equal. Again, like take the economical growth, okay? How was the lockdown impact, the effect of the COVID on the economical growth of the country? Economic growth, let's say the current year and the COVID the last time. You can check it. So still there is a case. Or the health condition of the population from the last year and how it will affect the current position. When it comes to the strict exogeneity, its idiosyncratic errors are uncorrelated with the explanatory variables at all time of the periods. Like 1 year back, 2 years back, 3 years back. Okay? Exogeneity, it's an issue. We're going to come and we're going to talk more about this endogeneity and exogeneity when it comes to time. But for now, we have to know that it's a problem with the previous lags, okay? Like previous factors affect current factors. We have independent variable, like we have a econometric model here. Okay, y is equal to beta 1 and x 1. Something from previous year affects the x1. Something 2 years ago happened and affected x1 too. This is called endogeneity issue. So there are some methods used, there are some techniques are used to handle it and to fight it, which I'm going to show you too as well, like using the two SLS, like two instrumental variables. But now we only have the problem of like those errors affecting the x. pooled OLS, okay, when you just come up with certain random and fixed effect, there's a thing that you need to select whether it's a random or fixed, and you just define it with the help of the Hausman test. You find it out that you're gonna use the fixed effect. But why not the pooled OLS? Pooled OLS as suggests like they're like cross sections, and you can use them together, different time periods. However, you have to come up whether if you're going to use the fixed effect or pooled OLS here. Again, we do the sum testing. And same thing with the random effect. If you select the random effect, you make a test whether it should be pooled OLS or random effect. So the process of looking the best model is called like specification search, and often we start with a general model and we drop some insignificant variable. So how we know that the model is really best model that we selected? How do you know that X1 is the best and X2 is the best that you select? Maybe there's some X3 and X4, X5 models, variables that you have not selected could replace them, be better. So there's another test that can be run and try to understand like whether the model is really fitted or not, which we can do it as well, like which is called search model by dropping, adding, and playing with this. And successful empirical paper combines a careful, like convincing data analysis with a good explanation and clear exposition. So whenever you get your estimate, there's a technique to make an explanation and interpretation of your results. It's not like this variable has got the positive impact on this. No, it does not limit the explanation to what I just said. You need to give more elaboration, more detailed one. Like you said that inflation has a positive impact on the banking profitability. Okay. First, why? Give the logic behind this. Why it could have a positive impact? Why in the case of Kazakhstan? And compare your findings with the previous findings, whether they match or not. And the third, compare with does it support a certain theory that has been developed before, like economic of scale? What was the economic of scale? Less input, more output, okay? As the company grows, it brings more money. But let's say you found it something opposite, that the bank, if they increase the size, the profit of the banks falls. So it just goes against the economic of scale theory. Then you have to just give the explanation why the theory of economic of scale is not supported by your findings. You should kind of defend yourself, like your findings are good ones, but you have to defend it. Then when you finish with literature review, methodology, data collection methodology, results, then you can move to introduction. Then you can start writing the introduction, in which you will state the basic objectives, explain why your topic is very crucial, why it's very important. Okay? And basically, in literature review, like what has been done before, how do you add to what already published? What is your uniqueness? What is your originality of the work? You need to grab the attentions of the readers by presenting some simple statistics, some paradoxical evidence, like some topical examples, maybe some challenges to common wisdom. Okay. You might give like a short summary of the results in the introduction as well. Now, conceptual and theoretical work. In literature, it's very important part. Okay, you have summarized all the previous studies. That's totally fine. There is a way to do it, okay? Which I'm going to show you as well, which I'm going to tell you how to write the literature review in a detail. But this is part very important in the literature part. As a separate paragraph, there should be a theoretical framework. For example, I want to test the theory of the economy of scale. I'm going to write everything about the economic of scale, who developed it, how it's used, and how it's derived, like in the literature. This is like, you can test different theories. For example, at least in your thesis, one theory should be tested. Capital structure theory, Miller and Modigliani theory, MMM proposition 2. Do you remember? Proposition 2. Do you remember? Proposition 2 is the theory of the economic of scale. Proposition 1 is the theory of the economic of scale. Proposition 2 is the theory of the economic of scale. Proposition 3 is the theory of the economic of scale. Proposition 4 is the theory of the economic of scale. Proposition 5 is the theory of the economic of scale. Proposition 6 is the theory of the economic of scale. Proposition 7 is the theory of the economic of scale. Proposition 8 is the theory of the economic of scale. Proposition 9 is the theory of the economic of scale. Proposition 10 is the theory of the economic of scale. Proposition 11 is the theory of the economic of scale. Proposition 12 is the theory of the economic of scale. Proposition 13 is the theory of the economic of scale. Proposition 14 is the theory of the economic of scale. Proposition 15 is the theory of the economic of scale. Proposition 16 Like so many, okay, it's like don't like asymmetric information, lemon theory, like there are thousands of theories, but in here, one more thing that you can develop your own theory. If you think that this is really good theory and it's illogical, you can state it, you can develop here too, and you can add it. You can, for example, go and search some medical part of the research, medical science, okay, some more engineer science, see what theories they use there, and you can, maybe you can use it in finance. Do you know the rule of 72? Have you heard about it? Rule of 72. This has been developed in 1459 by Basilio something, I don't remember the full name. He's a mathematician, and he has not give any proof where did he get it from. He just used it in his math book, okay, there's a book. He used it there, and the finance people, they used in the finance and they created a new theory, rule of 72. Do you know what does it do? It tells like, if you have now $100 and you want to double it, make it $200, okay? If you know the interest rate is 10%, how many years you should wait in order to double your $100? Just basically 72 divided by 10, it will give you approximate number of years. And you can try check from Excel spreadsheet, financial calculator, it will be close more or less. Like you need at least 7.5 or 7.2 years to double your income with a 10% interest. You can try in Excel, try to find it. It's gonna come. This is like rule of 72, and it was not created and invented by Basilio in 1459. He just mentioned it, but he has not provided any reference for it. Where did he get it? Did he create it himself? And the finance people, they used it in their book, like Brooks, Body. These guys, they used it, and they used it. You can do the same thing. Just search mathematicians, search any, like we have good real mathematicians here. Ask him, like he can share some information that we can use in finance. It's really good. So you have to develop and specify econometric models and estimation methods. This is the econometric model, how it looks like. We already discussed and we have already given the example. And after, like, when you specify the population model and you describe the estimation method, describe how you measure the variables and in your population model. When using the OLS, discuss why exogeneity assumption fault and how you deal with the heteroscedasticity, serial correlation, and so on. Like how you deal with other problems, like when you use. So, for example, when you use the OLS, you assume that there is no any problem with the data. Data is pure, like an angel. There is no any issue with the data. Okay, there is no, it's purely, there's no other factor that can affect your data. That's why you're using OLS. If there's an issue that you find it like using different tests, then you should refer to like QSLS or instrumental variable that will explain you or how to omit the endogeneity issue. So carefully describe the data used in empirical analysis. So in the data part, you have to carefully describe it. You have to give the source of data, where did you collect the data from, and you have to tell whether it's a time series or panel data. If your data self-collected, include the copy of questionnaire, discuss units of measurement of variables. You know, sometimes some journals, they do require, please submit the data set that you have collected. But you have a chance to object it, like I don't want to share it with anyone. This is my data set. I spent the time, like 1 year of collecting it. I don't want to share it. you can do it easily. But there are some journals, they do have requirement. And always, like, you should, whenever in literature, so in methodology or data part, we have to specifically show what is your data type, what you have it, but you don't put all your data there. Like I saw that some of the students might put what they did, they just put all the Excel file there. But if you put Excel file, it's like takes like 100 pages plus your thesis 60 pages, in total 160 pages, which exceed even the thesis of the PhD students. So don't put all the data there. Just specify with the summary statistics, mean, like maximum, average, standard deviation, standard errors, and so on, and number of observations. At least the audience, the reader, when he will read, he will understand what type of data you are using. And results, present estimated equation. If there are too many, present the tables. Always include like R squared, number of observation, whether did you estimate the coefficient significance, economical significance. The coefficient do not have to be expected sign. So this may be indicated in their specification problem. And relate to difference between results from different methods, difference in assumption underlying these methods. And of course, when it comes to the conclusion, summarize the main results and conclusions from them. Discuss some potential issues with a conclusion drawn and suggest direction for the further research. And there are some style hints that you can use it, like choose a title that exists, exciting and reflects the paper's topic. And nowadays I'm using like AI technologies to come up with a certain very beautiful title, okay? That will be fancy and that will be really attractive. Like you can go to the ChatGPT, write, please, these are my key factors, give me a really good title based on this. And it give you really like 5 or 6 titles and you can select there. Use it properly in an ethical way, the artificial intelligence. I don't know whether you heard it or not, maybe you have already experienced it. There's a Q bot that helps to paraphrase and in a way that, for example, there's a paper, you got that paper and you want to paraphrase it. You put into that Q bot and it paraphrases everything. You want like expand it, you want shorten, you want like more fancy, you want more scientific, which way you want that it will paraphrase it to you. However, Turnitin, it's a plagiarism check. It detects that the Q-bot too, as well as the ChatGPT. Before it didn't, but now it detects. So please be careful when you use this type of AI technologies. So otherwise you're gonna have the problem like you will spend more time on recorrecting and so on. Because there was a case, one scholar in chemistry used to write 1 paper per day. And he used to publish. Everyone was shocked. Like he wrote, imagine 1 paper per day. And he used to publish 1 paper per day, publish 1 paper per day, publish. And he was teaching, he was working, he was doing his like thing, but at the same time he was writing. And he was using these things. And what happened? He was disposed at least for 20 years from academia. Like he cannot return back. But he was disposed not because of he was using AI technologies. He wrote related to Russia and the European Union. He was working in university in EU, Italy, if I'm not mistaken. At the same time, he was representing one of the Russian universities, because Russian university, even Kazakh universities, all the CIS countries' university, they even including Turkey, they do hire researchers. They pay the money for them just to include the name of the university as affiliation. They pay really good money. For example, they get in touch with you. Please just get our university affiliation as a second affiliation at when you're going to publish, and you will be paid a salary, regular salary, or based on each paper you will pay. Because publication is required for the university to get in a higher ranking, in times higher certifications, in other accreditations. Like all the rankings, they require the publication. Like EFMD, nowadays it's like world's one of the toppest like accreditation, and the KIMAP got it. It's the first university in the Central Asia. The first thing that they pay attention is to the publication. How the key map dedicates to the publications, like to do their research. Do they do research, and in what journals do they publish? And key map was successful, and in terms of publication, in terms of teaching, we responded to all international criteria that have been set in front of us, like by EFMD accreditations. It's a European accreditation, which means that with this diploma in EU, you can work and apply for any programs that will be recognized. And KIMEP is the only university in the Central Asia that got the EFMD accreditation. It is the toughest one. In Turkey, there's 1 or 2 schools, universities, more than 200 universities, but only 1 or 2 got it. And the KIMEP in Central Asia is the only one. And wherever you go, everyone is asking about the accreditation because it's a kind of big asset for the university. Like FIBA, it's very good too as well. So number equation and the graphs and tables refer to the papers by author and date. Like example, like White 1980. Like for example, when you use referencing, okay, I don't know, did you involve before or not in writing the scientific paper? Most of you maybe already did it. If you're using it, like there's another AI technology which is Mendeley. Have you heard about it? It's very good technology. Use it in your writing because it will put you, for example, whenever you're typing something in words, okay, I will demonstrate later to you how to use it. You download the Mendeley and synchronize with your Word file. And whenever you will be typing, for example, just typing the name, before the typing the name of the author is in the Word, in the place of references, insert the citation. And you insert this author, automatically in the reference part below, it will put the bibliography itself. You don't have to find it in a certain format. Like we are following APA format, so it will do everything for you. You don't have to do it manually. And it will order it like from a scanning order from A to Z. It's written like Mendeley. And on the other side, it's your database because it will collect all your articles that you have read, that you have downloaded. It will be in one place and you can access from any place, from any computer. And whenever you put any econometrical model, okay, each variable, each coefficient here that you use it should be explained. Don't put it, this is my econometric model, and let the author guess what it means, each variable that we have it here. So each variable should be explained. And when it comes to the tables, okay, if you put the table of the results, everything should be explained here with the notes, okay? What does this mean? Like this bracket, what does it mean? What does this number mean? What is the name of this table? What are you doing here? What are you representing? For example, abbreviation here. Can you understand what here means? Except this like constant sol. What does the sol mean here? And rate, what does it mean? And I don't know. Put the notes here, like please refer to another table that gives the definition of these variables. Okay, this is done. Now we'll move to the STATA. Sorry, I just finished it, but didn't ask whether do you have any questions, any comments you'd like to make? Okay. I think you already knew the more or less the information that I have just shared with you, but we put it everything into a more organized way. Now, I will use the data here. I will Excel spreadsheet, browse the data. I'm going to use this import. Let's say I'm going to use this.
What do you say the name of that is? The name of that. The name of that application.
Mendeley. I will just write it here. Look. Mendeley here. Mendeley reference management software. It's really good one. You can download for app and like so on. Let me just download it. Maybe it will download. Yeah, it's for references and for your own to create your own database. Okay, while it's downloading, I'll just. Okay, I imported. The first thing I start in here, I need to declare my data set. My data set in here is panel data. So xt set by ID and years. Okay. Okay, then I can sum. For example, I want to sum the ROE, theta, this cost to income, liquidity, and z-score. Like I'm gonna use these variables only. Z-score, it shows the stability of the banking industry. This is liquidity. This is cost management, okay? The efficiency. This is credit riskiness of the banks. And this is the size, theta, like total equity or total assets. I'm gonna sum first. So look here. The maximum is 237%, like it's acceptable ranges. Imagine I have it here like 10,000. I had it before in my data set. I have those data sets still with me, like in L Drive. I can share it if we will have the time. But here, look, everything is fine. Mean like minimum is 0, totally fine. On average is this, good. And observation, this is the number of observations, which is very important for the authors and for any like supervisor. They are very concerned how many observations you're using. Because for the regression to be valid, it should be at least having 47 number of observation. If it's less than 47 observation, then your research will not be valid. So the observations are, it's a rule of thumb, okay? For the regression analysis to be valid, it should be 47. If it's in here, we can see it's like 1,595. Good, no, not bad. And z-score here and so on. Now I can do the same thing. Okay, here, oops, here. I will do correl. Correl means correlation between the variables. I want to see how they are correlated. Is it high or low? If it's too high, it's really bad. In some cases, like more than 50, it's a kind of signal for you. There is a problem with the model. Like any variable here. Check here. I don't know whether you can see it or not. Like, I don't see any like 50% here. Like they're all less than 50. Good. The model is good that we have selected. Still, like first correlation. What does this correlation tell you? For example, I want to see the correlation between return on equity and size. There's a negative correlation, which means if size increases, return on equity goes down. So economic of scale tells us increasing in size, profit goes up, but this is opposite. So goes against the theory of that. But it doesn't necessarily mean your work is really not qualified. Your work that you have collected data is not really good. No, it doesn't mean. Because of these countries, for specific countries that we have collected, we have got this type of result. But this is not the result. It just shows you the kind of prediction sign that we expect. Then we do the regression, okay? Regress. And we get the regression analysis. Okay, well, I'm not going to interpret the regression analysis. We know how to interpret, we know how to construct the econometric model on this, but this is a simple regression, which is ordinary least square that assumes there is no problem. There is no autocorrelation. There is no serial correlation. There is no heteroscedasticity. There is no multicollinearity. There is no endogeneity. Like everything is fine.
However, we cannot use it. As we said, there could be cases that some unobserved individual effects have impact on regressors, on independent variables. So we need to use the fixed effect to control it. Okay, we are using the fixed. Why? Because here we have 9 countries and 325 banks. The policies, the culture are different. So definitely there's something outside factor can affect independent variables. So we need to take it control. We may use the fixed effect. To use the fixed effect, instead of writing regress, I will write XT-rec. And at the last, I have to put FE, which represents fixed effect. Okay, this is the fixed, but this is not the result that you should interpret. You need to store it because you remember I told you from the beginning, there's a fixed effect and random effect. We have to select between fixed or random. This is our expectation that something outside can have an impact, but we don't know. The STATA will show whether there is or not. So we store it, estimates store fixed effect. Okay, like I'm giving command to save it before I run the random effect. Okay, then I'm gonna run random effect. I will change this to RE, which means random effect. Same, I'm gonna store it, but I'm gonna store it as RE. I'm not interpreting anything, I'm just doing the test, which method is more appropriate to our data set, fixed effect or random effect. I stored it. Now, I will do Hausmann test. It's a Darwin-Wu Hausmann test who has created this, okay? He has found it out, this random and fixed effect. Hausmann. Fixed effect and random effect. Now, the result that we're gonna get it here, this, okay? In order to accept the fixed effect, in order to use the fixed effect in here, it should be 0. It should be less than 1%, it should be less than 5 or 10% significance level. If it is not less, then we use the random. Am I clear? One more time. I will type it here. To use, make it bigger. To use fixed effect model, prop chi-square, okay, should be less than all level of significance, at least from one of them. Either it's a 1 or 5 or 10%. 1% or 5% or 10%. Now it's like 0.53. It is more than 1. It is more than 5. It is more than 10. So Hausmann test suggests that we need to use random model. So we use random here. Is that clear? Now we have come up with a random effect. However, random tells you what? Random model tells you that error terms are not correlated with independent variables. This is what the random tells you. So whatever fixed effect was assuming that the error terms are correlated with the independent variable, that's why we need to fix them to control it. But the random says, no, they are not correlated. We just run it because everything is randomly selected and they are not correlated at all. This is the assumption of the random. And that's why the random used to have the impact. On the other side, there's a pooled OLS code, okay? Now you need to use another test to understand whether you should use pooled OLS or random to kind of provide the justification of selection of the randoms, okay? Which is called Bruce-Pagan test, okay. Bruce-Pagan. ML test. ML, it's sorry, LM. Lagrange multiplier test. LM test. Bruce-Pagan that shows the presence of random effect model. Just justifies your selection, okay? You need to justify. You selected between random and fixed. You said Hausman test suggested that random should be used. And you use this Bruce-Pagan Lagrange multiplier test to just justify your selection, that your selection was correct. Okay, now I'm removing this all. And to do that, I will use, it's very simple, xt test 0. Okay, here, Bruce-Pagan Lagrange multiplier test shows that random effect model that we have selected justified. So we don't go for pooled OLS because significance level tells you you should go for random effect. So it shows refusal of the pooled OLS. So the results justifies the selection of random effect model by refusing pooled OLS because probe value is less than 1% of level of significance. Is that clear? Now we can go and run our random effect model, which we already did it. We have to run it again here. And now we can make interpretation. Now you can interpret your model based on this, like R square, wild chi-square. By the way, wild chi-square, it is same as F statistics. Like you remember F statistic that we use for the whole model best fitness justification. Like at the end of the day, we just make best fitness, whether the whole model is best fitted or validated, we use F statistic. In here, we're gonna use wild probability chi-square instead of F statistics. And the rest is the same. So this is the steps that you need to follow. And in the exam, I'm gonna give you the data set, which you're gonna run. Either it's a random, fixed, or this. And then you're gonna do your interpretation. Okay? So this video is recorded. I'm gonna share it with you too. If you will need it to rewatch it again, you can rewatch it. Okay? And anything else I skip here? Let me just check. Like, okay, everything is done here. Now, I'll stop recording.